Welcome to Web Handling. My name is Dave Roysam. I am super excited to continue our new series called Insular Industries. Here we highlight some of the cultural blind spots some mega industries have in certain web handling areas. Printing is another one of the oldest and largest of the web industries. If they can have cultural blind spots, pretty much anyone can. In this week's show, we will cover defect naming, precision roller alignment, tension control using load cells, and proper core sizing. I know your time is precious, so let's get started. Printing is one of the oldest of the web industries, almost 200 years old as a moving tension strip. Printing is also one of the largest in terms of numbers of converting machines. One count had the number of web converters, excluding printing, to be about 5,000 plants in North America. However, that same source estimated that there may be as many as 50,000 plants that do roll-based printing. Of course, many of them are quite small, such as your neighborhood copy shop or photo film printers. Yet, printing had and still has a number of cultural blind spots. They included only a rudimentary knowledge of the raw material they were buying, as well as certain aspects to mechanical and control design of their own machines. Sometimes it is helpful to see where we've been in order to better see where we are and where we might be in the near future. Mass printing, instead of hand copying, began in 1440 with the invention of the famous Gutenberg press. While this increased printing rates by orders of magnitude, it is not web handling. That began in 1843 with the Hoe press, which is a roll-to-sheet operation. Let us fast forward to the 1960s, where a substantial improvement in web handling began. This is in large part due to the paper mills teaching their printing customers some best practices that the mills had already known for some time. This began with clearer communication between the mill and the printer on the names of paper and winding defects. Classification and thus unique naming is the first step on the road to troubleshooting. Other things that the paper mills did for their customers was to teach them best practices related to roller alignment and load cell tension control. However, these teachings were not always and universally appreciated. Perhaps the biggest missed opportunity was core sizing that had to increase as roll sizes increased. Almost independently, we saw digital printing skyrocket about the year 2000. Here, digital printers did not have the legacy and inertia of the 150-year-old flexible and 50-year-old rotoprinters did. Thus, digital printers went from concept to space-age designs in just a few short years. The paper industry was the first to standardize the naming of roll and web defects. The first prototype was a widely distributed book titled About Newsprint, written by a large paper company and distributed to their customers, as well as used by their competitors. TAPI is the largest paper trade organization and one that we all owe a huge debt of gratitude, even if we don't make or use paper. That is because they standardized testing and teaching. After some early efforts, they published the Roll and Web Defect Terminology book in 1993. That covered most defects you would ever see in paper. After several more editions, the book was greatly expanded to include a wider set of defects found in other non-paper materials. The ultimate roll and web troubleshooting guide is one of the 2 must-have textbooks for every library. It is a veritable encyclopedia of proper names, causes and cures, and other information on more than 500 defects. Precision roller alignment was essentially invented by the paper mills because paper is demanding in that regard. Else, you greatly risk the web breaks and wrinkling. When I say precision, I mean routinely achieving real-world accuracies of better than the thickness of a human hair, or about 5/1000ths of an inch, or about 125 microns. For more than a half a century, there was only one set of tools that could achieve that, and that was optical tooling centered around theodolites, telescopic transit squares, and precision sight levels. In the last 20 years, we saw the invention of a precision gyro from only one source and precision lasers by 1 or 2 sources. While these instruments only approached the accuracy of optical tooling, they were much faster to use. So proficient were paper mills in this alignment that they not only taught their customers, for the most part printers, how to do this, they even did the alignment for their customers. Some large paper companies kept several alignment crews on the road, servicing their printer customers across North America. The entire paper chain benefited from this unique customer-supplier program. Registration is the color-to-color accuracy in the final print. Registration is quite sensitive to web tension. Web breaks are even more sensitive to web tension. Yet, for more than a century, the printing industry did not have any way to know what web tensions were on their printing presses. Paper mills came to the rescue by showing their customers how easy it was to install load cells and how useful they can be for process monitoring and troubleshooting, even if the load cells were not used for motor control feedback. The printers then also learned from the paper mills, who were among the first to do AC vector and later servomotor control. The result was the so-called electronic line shafts that reduced mechanical complexity and, in many cases, improved registration quality on a wide variety of web machines, including printers. The 1970s saw a rapid increase in roll widths and paper roll diameters. That, in turn, caused an enormous increase in several types of core or near-core defects. That should be no intuitive surprise, and the details of what, where, and why are well taught in my award-winning and trademark Web 101 class that has been taken by 5,000 students. In any case, paper mills provided massive incentives to their printing customers to increase core sizes to help mitigate this rapid increase in waste and delay due to supporting heavy rolls on too small cores that were no longer up to the task. Mills went so far as to even offer to rebuild their customers' chucks and shafts to take the needed larger core diameters. It is interesting to note the cultural differences in outcome. While Europe eventually updated core diameter for larger finished roll sizes, the United States, for the most part, stayed on 3-inch cores and still do. Printers and mills alike suffered and still suffer from undersized cores. For a century, printing was either flexo, for shorter runs or gravure for long runs of high-quality magazine papers. These industries were so large and so old that they became insular, and as a result, were largely unaware of web handling, with the exceptions that we just discussed, which came, for the most part, from their suppliers. However, digital printing did not have that legacy and inertia. They only had ink and inkjets, and had to start from scratch with machine design. They literally went to school and thus jumped into the space age almost from the start. Some digital printing press manufacturers use exceedingly sophisticated engineering design analysis. Their rollers and frames are no more or no less than just what is needed for the job. They also began with servo-controlled motors without ever having to work with the legacy of DC motors and line shafts. They also pioneered massively powerful computers that could handle the process of the firing of thousands of inkjets so that each page of a job could be different than the preceding, and to do so at blinding speeds. Perhaps the only thing else close in computer horsepower is found in paper mills with motor control and optical defect detection. Thank you so very much for joining me in this Insular Industries mini-series. Please join me next week, where we will continue our discussion of cultural handicaps by critiquing another of the mega industries, film. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.